today we are doing lesson 3.6b, which is solving proportions using cross products. We're going to focus today on similar figures. So similar figures, we have 3 bullet points here that we need to fill in. First of all, our similar figures are the same shape. Even though they are the same shape, they are going to be different size. So these dresses are the same shape, but they're just meant for different size people. These pumpkins are exactly the same, they're just different size. A word we use to describe both of these, the same shape but different size, is proportional, which we've been focusing on solving proportions. So they are proportional to each other. So here are some examples that are not similar figures. These are both triangles, but they are not the same shape. They are different sizes, but they don't even qualify as similar figures because they're not the same shape. Same with our bulldog here. It's the same image, but they're not the same shape. You can tell this one is kind of stretched to be longer, so these are not similar figures. So let's take a look at slide 2. It says write the ratio of the corresponding side lengths and then set up a proportion to solve for x. So these are the same shape, just different size. So this base of our triangle here is in proportion to that base. So we know we have x over 21 for the ratio of those two sides. Ratio for these sides here, I put the big triangle first and then the little triangle. So anytime we do that, we need to set them in the same proportion, same numbers on the top and the bottom from one triangle to the next. If you did the little triangle first, that's fine. Just have the little triangle in the top on all 3 proportions or fractions. So we have 16 over 12. These are all proportions that we're going to set equal to each other. We also have this side, 20 is to y here. Those are the ratios of our corresponding side lengths. We know each side goes with each corresponding side. So we only want to solve for x, so we don't need this piece at all. We're going to ignore that one. And we have x over 21 equal to 16 over 12. And I'm going to cross multiply to solve. X times 12 is just 12x. 21 times 16, I don't know what that is. I would probably use my multiplication table or a calculator to solve that. So 21 times 16 gives me 336. And then we need x by itself, that's multiplied, so I'm going to divide by 12. 12 over 12 eliminates. And 336 divided by 12 gives me 28. Now think, does 28 make sense for right there? Well, it has to be bigger than the other triangle, the small triangle that we had. It was 21, so yeah, that does make sense that 28 could be that length. Next, let's take a look at some error identification. It says identify the error and write the correct proportion. So we have our 2 triangles here. I'm just going to make sure I know which sides are corresponding to each other. So our smallest side right here we have is 3, smallest side here we have is 1. The longest diagonal side opposite of our right angle there, we have 4 and 12. And then last, the third side here, oh that's a thick line, is right there. Oops. I'll make that a little bit smaller. There we go. So they set in proportion or corresponding sides to each other. They have 1 and 12. So they took the short side, and that's not even corresponding. If we have the short side on this, we need the short side on this triangle as well. So this should really be, instead of 12, it should be 1 to 3. And then they did the diagonal side here, 4 to 12. So they had these 2 numbers really mixed up. They did not use the black sides that I had here. They just use the red and the blue. And if you were to solve this, they would be in proportion to each other. 1 times 12 is 12. 3 times 4 is 12. Yes, those sides are corresponding and proportional. So it says find the unknown side length. I'm going to set a proportion to find this. If I'm doing the tall side here, I'm going to have to set it in proportion to the tall side there. So 4 over, I'm going to say x, is in proportion to 6 over 17. If you had done the big picture to the small picture, you will get the same answer in the end, as long as you set them up same pattern each way. I put the small on the top and the big on the bottom. So when we cross multiply, we have x times 6, which is just 6x, and then 4 times 17, we would need to multiply that out. So when I multiply that, 4 times 17, we get 68. And then the opposite of multiply here is divide. So 68 divided by 6, it doesn't give us a really nice number. It gives us 11.3 repeating, or 11 and 1/3. Which, does that make sense? It should be bigger than 4, so yeah, that would make sense. Alright, next one. We need to be careful on this one. This shape is actually turned. This is the shortest side here, and this is the shortest side as well. So we need to make sure we're setting these in proportion to each other. So if that's the shortest side, the one to the left will be 15, and that one is 4. So I'm going to do the small to the big triangle. So 4 over 15 is equal to, and then we have the next side, x and 6, x over 6, and then cross multiply to solve. Doesn't matter which one you do first. I like to do the one with the variable, 15 times x, and 6 times 4 is 24, and then divide by 15. Again, you're going to want a calculator. It's not going to come out to be a whole number. 15 does not go into 24 perfectly. It gives us 1.6. Come on, there we go. 1.6, which you can tell based on these pictures that these are not to scale. Which means, look at this, you guys. This side is 6 and this one's 15. They look almost identical. So does it make sense that this one is going to be smaller? Well, yeah, because it's smaller in the large shape as well. So 1.6 would make sense for that side. Last two, a little bit of word problems here. It says, a person who is 6 feet tall stands next to a tree and casts a shadow that is 2 feet long. At the same time, the shadow of the tree is 6 feet long. How tall is the tree? Very important first step. Draw a picture. So I'm going to draw a person here and a tree. Here's my tree. Here's my person. It says the person is 6 feet tall, so I'm going to put a 6 by this person. And the tree, we don't know how tall the tree is. That's what we're trying to figure out. A person who is 6 feet tall stands next to a tree and casts a shadow that is 2 feet long. So this person's shadow here is 2 feet long. The sun is up here somewhere. At the same time, the shadow of the tree is 6 feet long. How tall is the tree? So we want to know this part here. I made them triangles because I assumed this whole piece would be in the shadow. That's from the sun, the rays coming down. So I'm going to set up my proportion. I'm going to do the heights first. 6 for the, I'm going to do the person on the top and the tree on the bottom. The person is 6 feet tall, the tree is x feet tall. And then the other side's the shadow. We have 2 over 6, person to tree. If you set that up a different way, there are multiple ways to set up proportions as long as you follow the same pattern. So multiplying here, x times 2 is 2x. 6 times 6 is 36. So we're just going to divide by 2. 36 divided by 2 should give us 18. That's one if you don't know, use your calculator. And we're talking about feet, so the tree should be 18 feet tall. Alright, last one. I would like you to try this on your own and then click play to see if you got it right. Model trains are proportional to real trains. This model is 30 millimeters long, so I'm going to make that 30. And the real train is 35 feet long. So here's our real train. I'm just going to draw a rectangle because I cannot draw a train. Here's our train, the little front piece. The real train is 35 feet long. This is millimeters. This is in feet. The height of the model train is 12 millimeters. So I know this is 12 millimeters. We want to figure out what is the height of the, how tall is the actual train, x. So what we're going to do, even though they're different units, we can still use a proportion to set up and solve this. So I'm going to go from the model to the actual and set up a proportion here. So first, my model height is 12 over the actual, which is x, and then the length's 30 over 35. This keeps all of our units in proportion as well, because then on the numerator we know our answer is in millimeters, and on the denominator our actual is in feet. So our answer x will be given to us in feet. So we're going to multiply here. 30 times x is 30x. 12 times 35, multiply that out. 12 times 35 gives us 672. Wait a second. 12 times 35. That's not right. 420. So we have 30x equal to 420. And then the opposite of multiply is divide. So I'm going to divide by 30. So we get x equal to 420 divided by 30, which is 14. And our denominator, or units, are in feet. So the height of the train is 14 feet. Does that make sense? Let's think here. This is smaller than 30. 14 is smaller than 35. They are in proportion to each other. Just making sure that we don't get a number that's bigger than our length of our train, because that wouldn't make sense at all.